Namaste to one and all, and I thank IKSL as well as all the organizing team for having put up this faculty development program and having given this opportunity for me to travel all the way from Varanasi to your campus. And thanks to all of you for your keen attention for the talk that I'm going to deliver. So as the title goes, I'm trained in physical chemistry, and as Dr. Richa had graciously introduced, I also have interest in history of science, and I have been dabbling on the contributions to chemistry in specific from the ancient and medieval India. So in that context, for this faculty development program, I am going to, the topic that was given to me are sources and texts. So this is a broad outline with which I'll be going around for the next 60 to 70 minutes or so. And I don't mind if you can stop me at the middle and clarify for any questions that if you may have. Just raise your hand and shoot the question. As a brief outline, first I would be beginning with our early literature corpus, starting from the Vedic corpus as well as a few glimpses from the Samhita texts. Then, more importantly, because the word source comes here, I'd like to spend a couple of minutes on the philosophical grounding of not just chemistry or material science, but also on the whole of Indian science itself. The other sources, prominently the science of chemistry or material science that our ancestors were dealing with, had to have a practical application, and it had a practical application in the health science, that is Ayurveda. So I'll be briefly spending a few minutes on the texts pertaining to Ayurveda. A very brief snippet from Tirukkural. We have this wrong opinion that the Dravidian is very different from the Aryan, so-called quote-unquote Aryan. But I'll be through one or two slides, I'll be showing you how it is connected. Then I'll be spending a couple of minutes on the text which is otherwise popular in political economy spheres but not in science. But all said and done, this is one of the early written texts that has survived the test of time and has reached to us in one shape. We assume it so. That is Arthashastra. Then I'll be spending a lot of time on the two prominent texts, Rasarnava and Rasaratna Samuchaya, which also happens to be the bedrock of the magnum opus by Prafulla Chandra Ray, Acharya Prafulla Chandra Ray. Thanks to him that we got to know about our own contributions in this field. And mind you, that book is almost 110 years old now. And as a mark of continuity, just introduce you to the work of one Bhudev Mukherjee, whose work is Rasajala Nidhi. And then if time permits, I'll be spending a few minutes on to show you, to convince you that whatever is written in these texts are not merely an intellectual or a verbal gymnastics or just a dry intellectual treat. We can translate that into experiment in the contemporary framework, and that's what I'll be briefly showing if time permits, and finally concluding with a summary. So very famous quotation from the Taittiriya Samhita, 14th book and 7th Anuvaka, that is the fourth book and 7th Anuvaka. Fifth one is the Namakam. It comes as a paired Namakam and Chamakam. The Namakam part is in Taittiriya Samhita 4.5 and the Chamakam part comes as 4.7. So it starts as Ashmachame, Mrittikachame, Girayashchame, Parvatashchame, Sikatashchame, Vanaspatayashchame. Then what I have shown you comes. Hiranyam chame, Yashchame, Shyamam chame, Loham chame, Trapushchame, Sisam chame. So these are 6 enumeration of distinct metals. There is a debate whether all are metals or one of them is alloy or not. Be that as it may, but these are very explicit name calling of metal and quote-unquote alloys as well. Why I am giving this benefit of doubt is that contemporary to P.C. Ray, there was another giant metallurgist who lived quite nearby this very place by the name Professor Panchanan Niyogi. And the National Metallurgical Laboratory, its predecessor, had commissioned several works, and two of these works for which Panchanan Niyogi is very famous for are iron in ancient India and copper in ancient India. They are monographs, and believe you me, that covers more or less an exhaustive account of both these metals right from a very early age till the era that Panchanan Niyogi had lived. And these monographs had come out in the 1920s, just hardly 100 years back. He has taken a different route of translating these metals, and he gives his own logic. I'll not get into the linguistic detail, but in the Shayanacharya's commentary, which is considered as a bedrock of or the hallmark of any Vedic text's commentary that we can access today, he has not used the word silver in this six metals, Shayanacharya. But Panchanan Niyogi differs, and he gives his own logic, and he translates his translation of these six metals, I put it in red. Okay. Now this calls for an introspection that ever since our ancient scriptures were written, quote unquote written, I'm not even considering the oral tradition, several thousands of years have gone by, at least 2 millennia have gone by. Even if we assume the Vedic corpus is hardly, say, 1000 BCE, as per the mainstream historians, which is again a date which is debatable. But even if we take that on the face value, at least 3 millennia have gone by. And in these 3 millennia, the words have undergone a lot of changes. The words have undergone a lot of changes. Now, the word Hiranya, today we understand it as gold. But Panchanan Niyogi argues that over a period of time, it actually meant silver. And at that point of time when this was being composed, it meant silver. Okay. And then Aya, even today this word is in currency, Ayaskanta. In some vernacular language, we still use the word Aya. In at least Tamil, it is being used. Kantam, Ayaskantam. But then the word has undergone a lot of meaning. At one point of time in literature, we see a very generic meaning of this word Aya. At some point of time, we see a very specific meaning of connoting iron. So the take-home message here, what I'm trying to drive, is that one has to be very careful and do an archaeolinguistic study in order to decipher the names from this Vedic corpus. Otherwise, we may end up getting either wrong information or perpetuating wrong information. By the way, this whole paragraph, the 6 metals have been highlighted here, but as I said, this whole paragraph talks about the materials. It starts from Ashma. Ashma is actually a stone. It could mean different varieties of stone. It could also mean the gemstone. Mrittika. Mrittika is nothing but your matti. The word matti comes from the root Mrittika. Now Mrittika, why would they ask for? Because that is the starting material for the porcelain that was being made for their day-to-day use. So the fact that they are asking Mrittika means they knew how to process it, they knew how to engineer it and tame it to the requirement that they wanted at that point of time. So even though we find the occurrence in the form of just one word, it enshrines in itself the know-how of the people of that time of how to engineer those materials. That goes without saying. Now we also see the mention about the soma. Soma is also a very ubiquitous word that we come across, and often it is either mistranslated, either by design or by default. But we do find copious mention of this word in the Vedic corpus, and at least to the best of my knowledge, scholars have not come to a consensus as to what it should mean at this point of time. A caveat I would like to mention, even though I have given the timelines for every slide, it's like debatable. It's the mainstream historians who believe this timeline, but these timelines are very much debatable, especially in the last 2 or 3 decades, where lot of research findings, new findings from areas like archaeology and genetics have made us rethink on these timelines. So really take these timelines with a load full of salt, and this is just for a marker for you to take you through at different points in time. Now, there is elaborate description of the preparation of soma as well. Different contrivances that were used, different filtering processes that were used. It is just to give a glimpse at how they were adept in processing organic stuffs as well. Like specific examples like admixture of a thick juice of soma with barley powder. This means that they really knew the art of fermentation. And we all know even fermentation is an inherent and inevitable part of every civilization, not just ours. But the art or the science here is to know when to stop the fermentation process or to detect whether it has got over fermented or not. Obviously, because the end product of fermentation is, today we know it as ethanol, but that is characteristic of its smell and various other microorganism growth that is associated with the fermentation. So even today, if something is over fermented, we know it is not good for our consumption. So whether it was known to them by serendipity or by hit and trial, that's a matter of speculation as of now. But the fact of the matter is that they knew it. They knew how the art of fermentation has to be optimized. Then there are again further evidences of this fermentation when we go down to Yajurveda, because there is a school of thought which believes that the early book is a Rig Veda and then what follows is a Yajurveda. There is an equally competing school which believes that chronology is not correct. All the Vedas, because Samaveda is nothing but a repetition of several mantras from the Rig Veda, just with the Saman added to it. So the contemporaneous existence of the Vedic corpus versus the synchronous appearance is something out of the scope, and it is still matter of deep research. But since the mainstream historians they are the mainstream historians, we have to go by what kind of dates they are giving or they are making us to believe. So in that order, we can place in this slide that I have placed Yajurveda after Rig Veda, but with that caveat which I have told you a few minutes back. If you look at a text from Brahmana, Shatapatha Brahmana, so there, this is an excerpt I have taken from the work of Dr. Satyaprakash. Incidentally, after P.C. Ray, talking about the secondary sources, after P.C. Ray, if anybody has done an exhaustive work on Indian chemistry, Indian material science, it is by Dr. Satyaprakash, who was head of the Department of Chemistry at the Allahabad University. And this book had come out in the late 60s. It's in Hindi. Those of you who can access Hindi, I would say it's a must read, because he has again given, P.C. Ray had at least concentrated on prominent 2 or 3 texts, but Dr. Satyaprakash has gone overboard and he has done a survey of majority of texts that he could lay his hands upon. So here is one excerpt that I wish to share, which talks about, this is a Ukha Sambharana of Shatapatha Brahmana, and Ukha is nothing but your cold boiler or the cauldron or fire pan. Now, when you read the description of it, the line that I have underlined here, और फिर इसमें अजलोम बकरे के बाल मिलाते थे जिससे मिट्टी में दृढ़ता आ जाती थी. That is अथाजलोम samsrujati sthemnen veva. The point that I am trying to drive home here is reinforcing. Today we know polymers are being reinforced for increasing their mechanical strength. So they have not used the technical terms, they have not used the jargons that today we use, but either by the hit and trial act or by serendipity, they have optimized a method to produce mechanically sturdy this ukha or this cauldron by mixing the porcelain or this mitti, the earth, with ajalom, that is the hair of the sheep or the goat. Now, some Sanskrit grammarians will make a play with the word aja, but here the aja actually means only goat and nothing to do with the one who doesn't have a birth or a Brahma. So there are a lot of pun associated with the word aja, but here it is to be taken for as only goat or sheep. So they were really, I would not say they were doing the tribological measurements or quantifying the strength of the material that they were making. That's definitely they did not do. We have clear evidences for that. But at least qualitatively they knew that if they engineer it in such a way, the mechanical strength would increase, with which the ultimate end product, what they desired, they could achieve. Now, coming to the philosophical groundings, I would recommend this exhaustive work by Dr. Brijendranath Sheel, Professor Brijendranath Sheel, who was a senior contemporary of Acharya Prafulla Chandra Ray. And he was almost contemporaneous with J.C. Bose, because as you may know, P.C. Ray had stayed with J.C. Bose for a couple of years when he had returned to India and trying to find a job. Brijendranath Sheel was a senior contemporary, almost like contemporary of J.C. Bose, and he was basically a philosopher. And if you see, there are a lot of, look at the dawn of the 20th century, there has been a lot of churning, as the churning is happening now, and you can see a lot of quintessential work pertaining to Indic science coming out at the dawn of the 20th century. So was inspired Brijendranath Sheel, and he writes this book, The Positive Sciences of the Ancient Hindus. And given his philosophy training in the subject of philosophy, he puts in English a firm footing for all the theoretical and philosophical basis of Indic science. For practitioners of Indian philosophy, they know that the Nyaya, Sankhya and Vaiseshika, these three darshanas among the Astika darshanas, they directly inform the science that evolved from there. Because whatever text we see, either the Samhitas, that is the Charaka Samhita or the Sushruta Samhita or the Brihat Samhita or the works pertaining to astronomy, right, from Aryabhata's time, or Aryabhata himself acknowledges a lot of scholars before him, all of them follow a certain common template, and that template is offered combinedly by these three darshana, Nyaya, Vaiseshika and Sankhya. And for the first time, Brijendranath Sheel puts it in the language that the Europeans could understand, and thanks to him that at least now we are in a position to reflect back on these. So, Tanmatrika Siddhi, Srishti, that's what, because ultimately the constituent of matter, what the whole objective of the darshana is to understand who am I, and if I am made up of matter, then what is matter? So the question goes ad infinitum in that direction. So like some examples, like here if you see, genesis of matter, the original infinitesimal unit of mass or inertia, absolutely homogeneous and ubiquitous, on which energy does work when the original equilibrium comes to an end, bhutadi tamasa hankara. The infraatomic unit potentials charged with different kinds of energy, which result from the action of energy on the original units of mass, that is a tanmatra. And the 5 different classes of atoms, the minutest divisions of which gross matter is capable, but which are themselves complex tanmatric systems, that's Sthula Bhuta Paramanu. These are all the building blocks with which the Nyaya, Sankhya and Vaiseshika builds, and Brijendranath Sheel draws a parallel to the science that has evolved from these texts. And we also know that, talking of the Genesis, the Shikshavali itself has got this Tasmadvat, Etasmad Atmana Sambhutaha, Akasha Sambhutaha, Akashat Vayuhu, Vayor Agnihi, Agnerapah, Adhyaf Prithvi, Prithivyam Oshadhayaha, Oshadhibhyo Annam, Annat Purushaha. So the sequence of the Genesis, if you may call it, has been echoed right from our Vedic corpus till the Upanishadic times. Now what this philosophical system does is kind of gives a theoretical framework to this genesis. How it does? Like it starts from Bhutadi, then Shabda Tanmatra, then Sparsha Tanmatra. Like it defines a Tanmatra and associates the Bhutas to these Tanmatras. So it kind of gives a theoretical framework to understand the genesis or the evolution of matter. Again, a caveat here, I am not trying to draw a parallel between evolution or evolutionary biology and trying to say that the evolutionary biology has got its predecessor in this Shikshavalli. I am not saying that. Okay, evolutionary biology, Darwin's or Lamarckian theory, those are a different dimension. I am not even coming to there at all. What this talks about is just to give, what I am trying to say is it gives a theoretical framework to understand this particular statement that we find it in the Upanishad. Like this Sankhya Patanjala system, it talks about the chemical analysis and synthesis, elements and compounds. All of you must have had chemistry at some point or the other in your time. Since many heads are going down either due to sleep or heavy breakfast, let me take a quick survey. How many of you are from science background? Oh, good, half the class. Among them, how many of you are from chemistry? Only 2. That's good. So thank you. You can put your hands down. For the benefit of others in that case, the whole starting point of chemistry is to define what an element is, how elements combine to form compounds, and how compounds are different from mixtures. When 2 elements combine, they can have a chemical reaction with them to form a compound. Like hydrogen and oxygen would mix with each other to form water, H2O. And when hydrogen and oxygen come and mix to form water, that is H2O, in H2O, even though hydrogen atom is there, its property is got completely metamorphosed. It has got completely changed. The property of hydrogen as in hydrogen gas is very different from the property of hydrogen as in water. So is the case with the oxygen. But if you mix hydrogen and oxygen and there is no chemical reaction happening and this is just a physical mixture, then the properties are retained. Okay. Now this, how the philosophical underpinnings here happens, I don't want to get into the hardcore philosophy of it, but it has to do with this Jivatma Paramatma admixture. Is one just a physical mixture or is it really a compound that one has merged with the other? So you can understand why the philosophical underpinnings come, from where they are coming. And it so happens that they apply those logical arguments to the matter also, and then the Indic science develops from there. In that context, you have this enumeration of elements and compounds, like saying the distinction between a chemical element and a chemical compound, or is there none? For an Advaiti, it is all one. Jivatma, Paramatma, it is Aikya. But whereas for a Vishishta Advaiti, he may say it's like a compound. For Advaita, he may say it is like a mixture. Both are completely separate. So this is just a very quick summary I'm trying to give you how the philosophy is really coming into the picture here. Now these are the questions of singular interest. What are those questions? Like, did or did not this physical analysis and classification of things lead on to a classification based on chemical analysis and synthesis? What this actually means, I don't know whether you had a session on Darshana or not, but all this Nyaya, Vaiseshika and Sankhya, they are obsessed with classification. Guna, Dravya, based on their touch, based on their quality. So the whole obsession for them is classification. Now if Nayayika or a Sankhya will ask, if I give you, if you are showing me some X, my whole obsession is to put that X in some classification. Once I am done that, I have had a control of it. And needless to say, the whole of science is also one kind of a classification. Even today that we are practicing, it's a kind of a classification. Why we would like to classify is because we have created those classifiers, and if we are able to place them in those particular classifiers created by us, we have a sense of authority on them. And so this Cartesian approach is that kind of a genesis that I have created the classifier, now I am comfortably placing them in the classification, hence I am the authority over it, so I know it. So the classification root comes from this kind of a thought process in my opinion, which are essentially a scientific question. Like for instance, all of you, some of you may not be from science, but I'm sure you will understand what solid, liquid and gas is. So all of you would have gone through some middle school or somewhere, right? Now if I give you a heap of sand, what is the textbook definition of solid? Anything that has got a definite shape and a volume. Liquid, it has got a definite volume but not a definite shape. Gas, it has neither a definite shape nor a definite volume, right? That's a typical definition, textbook definition of solid, liquid and gas. Now I give you a heap of sand. Will you classify that as a solid or a liquid? It has a definite volume but it has no definite shape. Will you call that as a liquid? So we are confounded with a paradox, so-called paradox, because the classifiers that we have created, now I am confounded with an object which I am not able to place within those classifiers. So I'll call that as an outlier, or I will say I'll have to modify my classification system. So this is also the contemporary scientific obsession of understanding the matter and appropriately classifying them. And that runs through right in this philosophical system as well. They talk of aggregates, samuha, being the intimate union and fusion being lost in the whole. Ayutta singa vayavaha samuha. Like when in aggregates, what I'm trying to say is there are definitions where the aggregates, the singular parts have lost their property or not lost their property, right? So then there are very emphatic chemical terms which are being used, like upashtambha, apashtambha or vishtambha, which are for liberation of energy. Either it can take away energy or it can give away energy, or it will be isoenergetic. Like today the reaction that we do or we understand, we say either it's an exothermic reaction or an endothermic reaction. What it means, exothermic. These are all Latin or Greek terms. So these terms we come across there, but here mind you once again, critics or detractors may feel that okay fine, today you are retrofitting these terms to suit your narrative. That is, you have this term upashtambha, apashtambha and vishtambha. You are currently dealing with terms like exothermic and endothermic. What you are doing is an intellectual leap by which you are retrofitting these contemporary terms to the ancient terms. That's a line of criticism, but it is a merely criticism for the sake of criticism, because we have enough evidence to show in the literature that they have not merely used these terms in a figurative sense or in a very superficial manner. They meant what they really meant by those terms there. Now another example, that Gangesh is another Nayayika, okay? So his famous work Tattva Chintamani, he conjectures that even gold can be evaporated or made to disappear by application of intense heat, okay? So why should a philosopher use an example of this kind, that gold can also be evaporated by the application of heat? When a concept of science comes into common society, which only means that the general awareness of that common society is up to that level to grasp, to assimilate, to appreciate that scientific concept. Okay, so the fact that they knew this phase change, what we today call technically the term phase change, gold from its solid phase will go to a liquid phase, will go to a vapor phase. This is what is quoted as an example by this philosopher here. Okay. In this context, I mean, I'm also reminded of an example that Adi Shankara gives to tell the place value system. For instance, if the shunya is placed in the shunya system, it is shunya. But if it is placed in the 10th place, it gets the value of 10th. If it is placed in the 100th place, it gets the value of 100. So is this Atma, if it is placed in this body, it gets this value. So it's like, you see the kind of conversation that the philosophers were having with the scientific concepts. Okay, so this example often I have heard in the lectures of Professor Ramasubramaniam. I could see that this is a counterpart in chemistry that we can see, that Nayayika is quoting an example of phase change, taking gold as an example. Yeah. Ayodhamstra, it is also called as Ayodhamstra. That is, I understand what you are trying to say. That's what I am saying. See, gold has also got a paryaya which is called ayodamshtra, or ayodamshtra means it is considered to be the damshtra is the teeth, but it also means in one more paryaya it comes as the tongue of the fire. Okay, so this analogy that you are trying to say is very much there. Ayo Tejas, we'll have to look at the contextual meaning there, because again here is an example where the aya is used for the word gold and not a generic metal. Okay, whether it is emphatically gold or whether it is any generic metal, that we'll have to look into. But among the Nyaya, recognition of gold as a metal was very much there. They might have used it in a figurative sense to convey some other meaning by taking an example. So this particular example I'll have to look into, and maybe after I look into again, I can shed some opinion on that. Coming to the Ayurvedic texts, again the philosophical underpinnings, they have lifted it verbatim, because in the Ayurveda the belief is that this Deha is again made up of the Pancha Mahabhutas. Whatever we see on the earth is composed of this Pancha Mahabhuta. So this Pancha Mahabhuta concept gets directly migrated into this Ayurvedic period and all the Ayurvedic texts as well. And of course we find copious mention of, as I said, the pinnacle of ancient Indian chemistry and material science was in the application to have a healthy and a long life. It was not just done for the sake of intellectual gymnastics. It was not an academic exercise alone. For them, the chemistry meant for having practical application, and specifically in terms of either alleviating the disease, thereby increasing the longevity and experiencing a healthy life till the last breath. So needless to say, they talk of lot of materials like Shilajit, which is bitumen, Mandura, Anjana, Suvarna, Ayas. But here you see in the Ayurvedic period, the Ayas takes a different meaning from what Ayas in the previous literature was. Kamsya, Gandhaka, Tuttha, so on and so forth. Interestingly, in the organic chemistry side, quote unquote, you have categories of Madira, which is a distilled wine, Madhya, which is a fermented liquor from barley, Mridauka from grape juice, Rasasava from sugarcane juice, Tushambu from fermented liquor from barley gruel, Madhvika from honey, Asuta, brewed mixture containing soma plant juice, and Akshaki. Okay, so you can see here how many types of different fermented beverages they are talking about. How to differentiate, they were able to differentiate it. And interestingly, in the Arthashastra text, I will not be talking about this aspect when I come to Arthashastra text. Kautilya designates a specific inspector for inspecting all these beverages. Okay, Somadhyaksha it is called. The classical Ayurvedic text also mentions about the 9 sources of fermented drinks: cereals, fruits, roots, wood, flowers, stems, leaves, barks, and sugar. And believe you me, these are not out of vogue. Like even today, it may not be an urban phenomenon, it may not be even a semi-urban phenomenon, but somewhere in the pockets of villages in our country, no matter which state, there may be a group of people, community, who may be still practicing such things. Okay, that's just that has perhaps escaped our gaze or attention at the current point of. And there are as many as 84 kinds of wine preparation. Now you may wonder what did they do with those wine? Of course they consumed. What did they do after that is a matter of our imagination. But all said and done, they had 84 different kinds of wine preparation present here. Again, Sushruta Samhita also gives an account of several minerals. I will not read out due to want of time. They had a very detailed process of differentiating alkalis. Like even today, the word kshara is in vogue. In Bengali also you have khara. In Tamil you have karam. Gujarati also you have khara. Marathi also you have khara. I mean, any vernacular language, have you used the word khara? Khara becomes apabhramsha of the original Sanskrit word kshara. That samyukta ksha becomes kha. Are you all familiar with this term khara? It's still used in the common household as well. But today in specific, it is used for what we call fitkiri, so white alum. In some communities or some states, it is now used only, the word khara is used only for referring that. Like in Tamil today, the word for alum or fitkiri in Hindi is karam, pidikaram. So the older usage of khara to refer to caustic or alkali is slightly out of fashion now. And interestingly, they obtained their alkali source completely from plants. Okay, so this makes some modern chemists believe that they were unaware of inorganic caustic compounds like sodium hydroxide, calcium hydroxide. They were unaware of. But that is something, a conjecture, which we may have to prove. So they knew what is a mridukshara, what is the tikshna and what is a madhyamakshara. And you may wonder why they needed to classify this. Today we know we can classify the alkali based on the pH. If it is pH 7, it is a very, very soft, mild alkali. If it is pH 10, 11, it's a medium. If it's pH 13 and 14, it's a very harsh alkali. And whatever harm a concentrated acid does, similar harm a concentrated or a pH 14 alkali would do. So now you may wonder what was the utility for our ancestors to use caustic alkali of different strength. They are multiple, they were processing minerals. For processing minerals they were using alkali, and for various kind of medicinal preparations as well. And not just that, they mentioned 6 types of salts, suvarchala, which is niter, potassium nitrate, saindhava, which is sodium chloride and potassium chloride, Vida, which is sodium chloride with traces of sodium sulfate, alumina, magnesia and iron compounds, Anubhida. Bida and Anubhida are still in vogue in Bengal and Odisha region, this term. Saline deposits of sodium carbonate and magnesium sulfate, and Samudra, which is a sea salt, sodium chloride, magnesium salts, and Romaka, saline that is obtained from the earth, Bhumija. This is still used in Siddha tradition, that at one particular point of time in a fortnight they will go in the dark and see the earth throwing out certain compounds, and that turns out to be some kind of a salt. Okay, so in this case again I would like to mind you a caveat here that although I have put the contemporary chemical symbol, I am not at all trying to hint saying that our ancestors used or described the salt in this language. No, I am not saying that. This sodium chloride, potassium chloride is our contemporary understanding of the ancient science. Because many times I am misquoted by saying the scientists from IIT said that our ancients knew sodium, NaCl. So that is not the purpose here. And they knew how to process acids from citrons, mainly tamarind, pomegranate. And here even P.C. Ray writes it very emphatically that the knowledge of mineral acid was unknown to them. Now that is something very contentious. The reason is, if you are to process metal, we cannot do those processes without the use of mineral acid. Okay. Now in the history of this development of acids, we come across a term called Shankhadravaka. And this term Shankhadravaka is still used by Ayurvedic physicians, and this particularly refers to sulfuric acid. Shankhadravaka. Dravaka was a term commonly referred. Dravaka was a solvent, but specifically Shankhadravaka refers to sulfuric acid, and that our historians have attributed to Persian origins and coming into the Indian text as late as 16th century. Okay, but I have certain reservations to believe that on its face value. That's something, it's a matter of research that I am particularly going through to unravel the mystery there. Then in the classical Ayurvedic text, we also find plants, of course, plants and their therapeutic values. The Bheshajya Shastra was very much there. Not only that, disinfectants and pesticides, how to use them, how to process them, were also very much described. Then, of course, you have this compendium of Brihat Samhita, which gives the account of some very interesting chemistry also there. The whole chapter on Gandhayukti. Gandhayukti is perfumery. There's a whole chapter dedicated on perfumery, where he starts with 16 base perfumes and poses a question that if I take 4 at a time, how many perfumes I can get. That's a matter of permutation and combination, but that also involves certain knowledge of basic chemistry as to which 4 will be compatible with each other. So that may be again by serendipity or by hit and trial. That's a matter of speculation, but they knew this. That's the fact of the matter. But beyond that, Brihat Samhita also talks about other interesting compounds like Vajra Sanghata and Vajra Lepa, which are adamantine compositions, and they consist of extracts of certain plants, fruits, so on and so forth. The process is described, and what is more interesting is this glutinous material could be applied onto the roofs and walls of temples and mansions, and its life has been stated to be 10 million years. Now even the Fevicol or whatever glue company that we come across today will not be in a position to give this kind of a guarantee, lifelong guarantee. So this also talks about contemporaneous application. There is only 2 papers till now I have in my literature survey that I could come across, which talks of reproducing and remaking this adamantine glue, Vajra Lepa or Vajra Sanghata. Now if you are in a position to remake it in a very, very efficient manner and also scale it up, this is a potential candidate for even a patent. So this Brihat Samhita is which also gives detailed information on the preparation and use of fine chemicals like perfume, scented hair oils, etc. About scented hair oils, there are a lot of interesting things. I will not get into the details here. Now coming to snippets from Tirukkural. So you have looked at Vedic corpus, you have looked at the classical Ayurvedic time. Tirukkural are very like haiku of Japan. They are 1.5 line statements of wisdom in Tamil language. Okay. Again, its date is unknown. Its author we know Thiruvalluvar. Again, the name is a very generic name. It's not a very specific name. But what interested me is the invocation of specific names of metals in these Tirukkurals. Like, for example, one here. I'll not read the Tamil part. I'll spare you with that. But what is interesting is the meaning of it. A ruler should not use harsh words nor give punishments that far exceed the crime. These are like metal files that wear down toughened steels. Citizens' anger will similarly wear down the all-conquering strength of the ruler. Now, what they knew is metal files and toughened steel. And when one rubs the other, it kind of wears it down. So, which means the abrasive property of the metals was known. They might not be, they definitely did not rank it in the Mohs scale that we rank it today. Okay, but this either by serendipity or by hit and trial, they knew the property and of what when one rubs the other, which one will be abrasive, which one will get the dent. Okay. Now, what I would like to draw your attention to are the types of gold which are described in Tamil Sangam literature. Okay, they are specifically Atakam, Sembon, Kilichirai and Navalam. These are the 4 types of gold, 4 names of gold that we come across in the Tamil Sangam literature, which are, now again the dates are debatable, but you can call them contemporaneous with either Arthashastra or before the Common Era. Again, Atakam, Sembon, Kilichirai and Navalam. Just have that in your mind. Now we look at the contemporaneous text Arthashastra, where you have, now again Arthashastra has been dealt with management people and political science people and economics people, but the science part of it is not much explored, I would say. Especially the book 2, the second book. It has got I think 7 or 8 books or whatever, Khanda. And the second book is entirely about materials, material science, metals, alloys, gemstones, minerals, all sorts of things that day-to-day life has to, we have to use in the day-to-day life. Like how I look at it, so today if you look at a custom document or a custom literature, contrabands, or when you do the immigration, how one country creates a database to say what kind of contraband is being brought to my country, or what kind of material resource is going away from my country. So for a country to develop that database, one need not be really a hardcore scientist. A custom official can do even today. All that they need to do is they need to compile. So perhaps like that Arthashastra, in the Arthashastra, Kautilya has compiled such kind of scientific information. Okay, I am not claiming here Kautilya was a chemist or a material scientist. Giving a benefit of doubt, since it is a state welfare document, he has not left any stone unturned to see all aspects that will lead to the welfare of the state. So in that aspect, the material takes a prominence, right? It comes right in the second chapter. So different descriptions of gold are given. Tathot Gatam Gaudikam Kambukam Chakravalikam Cha Rupyam. So I will not go into the details of okay, this is silver, not the gold, sorry. This is about the silver, Tuthot Gatam, which is extracted from the mountain. Then the descriptions of these metals are given, their sources are mentioned, how they are processed, and how to check the purity, especially for gold. He has gone in length to describe about different measures to check the purity of gold, and he has also laid punishments to say if the gold is found, claimed to be this but found to be this, what is the punishment? Which means back in that time people were doing some counterfeit also. It's a human mind which has been the same. It's not that everything was hunky-dory in the past. For Kautilya to put it in black and white as to what should be the punishment if the purity is below this, which means he found people doing it. Otherwise he would not have included those statements in his text. Interestingly, now you see, Lohadhyakshas Tamram Sisa Trapuvair Kranta Karakuta Vritta Kamsa Tala Loha Karmantan Karayet Loha Bhanda Vyavaharancha. So this is, he talks about a Lohadhyaksha, which is who is the superintendent of metals, which means he lays down all the characteristic properties of purities of metals, how to detect the counterfeit. Then superintendent of mint silver coins, that is Lakshanadhyaksha. So this chapter, various such descriptions come. Interestingly, this one particularly, Pratimananya Yomayani Magadhame Kalashailamayani cha Yaniva Nodaka Pradehabhyam Vriddhim Gache Yurushnena Vahrasam. This last word is very interesting. Vriddhim Gache Yurushnena Vahrasam. It means you should make your units of measures, weight, from a very specific iron obtained from such and such region, and such that it should neither expand when heat is applied nor contract when it is heat is withdrawn from it. So today what we in thermodynamics that we read about thermal expansion of metals, we use a different jargon, of course. I'm not saying he has used that jargon. No, I'm not at all claiming that. But the very property of the metals, that metals will expand on heating and contract on cooling, was known to them. But here, as a science student, you can ask a question. What if it expands or it contracts? The weight should remain the same, right? Why did he specifically mention that I should not use such a metal which expands on heating or contracts on cooling? What is why should it affect of that metal to be a weight measure? Something for your food to think. I'll not give the answer. So at least you think, and you can discuss it over later also if you need. About different occurrences of gold, I'll not get into the details due to want of time. Again, a matter of caution here because it's talk on sources and texts. Interestingly, the first guy who translated this, Arthashastra has got a very interesting story. I hope all of you are aware of it. Very briefly, I will say it was discovered in the Oriental Library of Mysore. And Shama Shastri was the guy who discovered it in early 20th century. So, the Mysore Maharaja, he writes it in his memoir that when he had been to Britain in the 1920s, there, when he was introduced, among the audience, one of them asked, it seems, that, are you from the city where Arthashastra was discovered by Shama Shastri? So Maharaja comes back and narrates to his subject, saying, for the first time, I was known by my subject and not the other way around. The subject was not known by the king's name. Okay, because in Sanskrit we say that Swadeshe Pujyate Raja Vidvan Sarvatra Pujyate. But here it is like opposite of it. This incident was really the example of that. Swadeshe Pujyate Raja and Vidvan Sarvatra Pujyate. Shama Shastri was a Vidvan and the Mysore Raja was the king here. So Arthashastra was discovered and it was rendered in critically in English. Later, somewhere in 1950s or 60s, the Banaras Hindu University, one Hindi professor had translated it. And he claims it to be the first translation of Arthashastra in Hindi. And he said he has used a direct text, the Sanskrit text itself. But a cursory reading of it will tell us the contradictions in the translations. For example, that Kinjal Kavarnam Mridusnigdham Anadi. That's a Sanskrit term found in Arthashastra. How does a Hindi translator translate? Thanthanane wala sona. And Kangle, how does he translate? By the way, Kangle is a very authentic translation. A Marathi, again a Marathi scholar from Maratha. His translation is considered to be the very authentic translation of Arthashastra. How does he translate? Incapable of making any sound. Now, those of you who know Hindi, Thanthanane wala and incapable of making any sound are diametrically opposite. And the Sanskrit term is Anadi. So, which one has to be taken? One has to be really careful in deciphering these terms, even from the secondary sources also. Okay, so the task is even more daunting to us because we have to keep the primary source authenticated and the secondary source to make sense out of it. Similarly, Sreshthanam Pandushvetam cha apraptakam. How does the Hindi translation go? Sresht sone mein se kuch safed rang ka sona nahi milta hai. English translation, impure gold is of whitish color. Diametrically opposite translations in Hindi and English. Now, what Kautilya would be thinking of it, we do not know, but task before us is not very easy. That's all. Bottom line is that. Another very absurd mistake in this Hindi translation that I could find, wherever you have this term, Kadali Vajra Kandar Vidyamanam Krutva, Sisa, Akarodgatam, Sisanvayena Vidyamanam. Sisa, if you remember, I had shown you the term from the Vedic corpus. Hiranyam chame, Yashchame, Sisam chame. Sisa comes from a very, very long time. So it cannot be misunderstood. Sisa actually means lead. But the Hindi translation, we translate it as Jasta. And you know what Jasta means. Even today the term is in parlance. Jasta, Jasda, Yashada. What do you call for zinc? No, zinc. That could be. What I'm asking is just a name. What do you call zinc in your tongue? Jasta, that's what. It actually comes from the Sanskrit term Yashada. And Ya and Ja are Abheda. So, Yashada, why Yashada? Because it appears like silver. It has got that Yasha. Yasham dadati iti Yashada. So that this zinc appears like a silver. So Yashada, that Yashada becomes a Jashada. Jashada becomes in colloquial parlance Jasta or Jasda. Sisa can never be a Jasda. Gillet. I have to think about that. हाँ समझ रहा हूँ वो गिलेट भी उसी में. In fact, in eastern UP side, if you go, the jewelry market is called the Gillet Bazaar. Okay. Now it's a good point of thank for that question. I didn't think about it in this context, but I'll give a thought to it. But it's a good point. Thank you. Anyway, due to want of time, I'll keep it short. Now this Arthashastra talks about the checking the purity of the gold. Okay. I'll not bother you with the detail of it, but sure you will realize what I mean. Even today, if you go to any small suburb jewelry shop, they would first rub the gold. If you're selling a gold ornament, they will rub it against a kasauti or a stone. And then they will put some acid and check the color change or not. Believe you me, this technology has been there at least from the time of Kautilya. It is a continued existence of one technology. Talking of some continued existence, there are only very few technologies that have survived. People talk of lota. The design of lota is from the Harappan age. The pot is from Harappan age. Similarly, this technology also should be considered in that sense of testing the purity of the gold. And its complete description, we find it in the Arthashastra, in the second chapter, the second book there. Okay, I will not bother you with it. Coming to iron, about this, there are texts, I have not gone into the detail, but starting from Rig Veda, Krishna Yajurveda, you have copious mention of iron and processing of iron. This is one example where the Ranchi, we're not very far from here, there is a state authority office, and there they have this painting. Can you recognize what this painting is about? Do you at least, can you say the context? This will also help you wake you up from sleep if you are. Yeah, it's a weapon, of course. Somebody said Alexander. That's it. Porus, whether he got defeated or whether he surrendered, that's we do not know. Depending upon which side of the border you are, the history will be presented in that way. It is said that Porus, upon defeating or surrendering, he is said to have said, "Treat me as a king who will treat another king." And in turn, he has presented him steel. 40 pounds of steel was presented. In fact, the commentator, he not only gives his sword, but there is also a servant or a helper standing behind with some kind of a box. That box is a golden box, and inside was kept the steel. Okay, so imagine at that time steel was considered much more precious than even gold. So no wonder we hear even during Vijayanagara time that the gold was sold in this wooden carts on the streets, whereas engineered iron is something much more precious. Now coming to the last 10 minutes perhaps, the two texts, Rasaratna Samuchaya and Rasaranava. Mind you, there are at least, to my knowledge, at least 80 texts pertaining to quote-unquote alchemy. Alchemy is a very different word. Many of the historians of chemistry in our country have attributed that to our chemistry also, but I completely beg to differ. Alchemy comes from an Arabic word, alchemy, and that has got a different kind of a persuasion, different context. I'll not get into the detail of it, but there are certain very golden misses also, right? For example, Nagarjuna's Rasaratnakara. Even P.C. Ray considers this book, Rasaratnakara, by a person called Nagarjuna as one of the earliest found text for Hindu chemistry. But it turns out that this Rasaratnakara text never existed. In fact, it is Nagarjuna was a Buddhist, and he had written two texts. One was Kakshaputa and Rasendra Mangala. The Rasendra Mangala was later rewritten by Nityanatha Siddha, who gave the name Rasaratnakara. There is a detailed work of it, a brief of it, I'll show it to you. But then what I'm trying to say is, 100 years back when P.C. Ray was trying to make sense of all these things, he also made certain very basic blunders. Yeah, so this is the scholarly work that I was talking about, an alchemical ghost, the Rasaratnakara by Nagarjuna. And just I would like to draw your attention to this, that there are at least 70 or 80 primary Sanskrit works on alchemy. Approximately 1/5 of these have been printed, that is less than even around 15 have been printed, few critically edited and none completely translated. This is the fate of this paper appeared in 1984. Okay, and at least 35 years have passed by since then. And to the best of my knowledge, the BORI, that is this Bhandarkar Oriental Research Institute in Pune, Pune, BORI in Pune, they had come out with one critical edition and translation just this year on the chemistry text. So there is a whole lot of text, at least we know of, that has not been translated or critically edited or even looked at. So Rasaranava, it was critically edited by P.C. Ray and Harishchandra Kaviratna. Kaviratna, Kaviraja, these are all suffixes given to Vaidya in the Bengal region. Kaviraj, Kaviratna. So they are not to be confused as a surname. And published in 1908 and 10. It's a rare manuscript found in the Raghunatha Library in Kashmir and Oriental Manuscript Library of Madras. Incidentally, just last month I happened to be in the Raghunath in this Raghunath temple. But very sadly speaking, the locals there, or at least to whom I asked in the temple, they were not able to show me the library. So in Jammu, I was there in the Raghunath temple itself. Despite several efforts, that library could not be traced. It has 18 chapters. Literally means a sea of mercury. Now rasa, of course, in the tantric context, it means mercury, but it is an all-encompassing word. Rasa could also mean essence. It's a dialogue between Bhairava and Bhairavi. In first 3 chapters are on student-teacher qualification, quality, etc. The 4th chapter onwards deals with different yantras and instruments, and chemistry of mercury really starts at the 10th chapter. Hg is for mercury, yeah. So, sorry, I had taken for granted that all. It's again comes from a Latin term called hydrogyrum, Hg. Sorry, can you please be louder? Rasarnava, yes, it very much exists. In soft copy also, if you go to archive.org, at least I have downloaded my copy from the archive site, Rasarnava. There are multiple copies of it exists. Similarly, the dates of Rasarnava are quite debatable. And like any other text of our country, the error bars in the dating run to centuries. Okay, so talking of Rasarnava, some people have given it as 8th century all the way till 12th century. So at least there is a 400 years of gap. I mean, can you imagine the kind of embarrassment that one would face if we are asked to date a manuscript which is spanning for 400 years? Within 200 years, we have come, what the technology has changed so much. Semiconductors have changed our lives in the last 100 years. Now we are talking of dating a text and placing it in a, smearing it all through 400 years. Okay, so that's the fate of our texts. Rasaratna Samuchaya, it is by Vagbhata. Vagbhata also has got another book by called Ashtanga Hridaya. That's more of a Ayurvedic text, which even today the BAMS students follow. But Rasaratna Samuchaya is more on chemistry and material science, how to prepare the formulations, drugs. It throws state of Indian expertise in extraction, purification, conversion of metals, minerals into therapeutically suitable forms, various instruments developed for alchemical purposes, treatment of numerous diseases by using herbo-mineral preparations. It contains 30 chapters, classification of metals, minerals, and it provides 31 different instruments required in pharmacy based on the description of Somadeva. Chapter 10 describes 17 types of crucibles, musha, their manufacture, the 4 types of koshti or the furnace, 10 types of puta, various sized pits for calcination of metals. Calcination means how to heat them at different temperature. I will not bother you with this minor details. This is about the Rasarnava. Various chemical processes like Shvedana, Mardana, Murchana, Utthapana, Patana, etc. And believe you me, all of them are still used in chemistry lab, but with a different names. Sublimation, distillation, crystallization, digestion. So all of them are still in vogue. Interestingly, in the Rasaratna Samuchaya, also in the Rasarnava, we find graphical description. Again, mind you, the picture is not present in the text. The picture is a retro imagination of an artist. Okay, this picture is not given in the Rasaratna Samuchaya nor Rasarnava. But what is given is in the text. How in the text an ideal chemistry lab is described. How it should have a cross ventilation. Where should you place toxic substances? Where should you place salts? How the salt should be prevented from moisture? Where the fireplace should be there. Those description, like how you would, like using those texts, you can construct a chemistry lab which would be very functional even now. It will not be out of vogue. And the kind of style of writing. See, this is the 4th chapter. As I said, first 3 chapters go into the qualification of the students and their teacher. And the beginning of the 4th chapter, it goes like this. Yantra mushagni manani nagnatva mantravedyapi kim karoti mahadeva tani me vaktum arhasi. Like one of the criticism that Indian science faces by the historians as well as the scientists is that many of them are only theoretical. Kapol kalpit baatein hain. Because we are not able to get the archaeological excavations. Right? Now, given the subject of archaeology developed in Europe, where temperatures are very, very different. In a temperate country like ours, an archaeological artifact to survive for several years is impossible. That's again my problem with the Indian archaeologists, that they adopt an archaeological template developed in the for the Western countries, in the Western countries, applied to Indian terrain. What kind of archaeological truths they'll be able to unravel is a question mark. So that is, be that as it may, that is accepted as a standard now, but that is applied even to science. And they say that you all do only theoretical gymnastics, intellectual gymnastics, nothing in practice. So the fourth chapter begins that, okay, fine, you have told me about the theoretical aspect. This is how the Bhairavi asks. Bhairavi is a like conversation between two people are happening. The one lady asks there, Mantra Vedyapi Kim Karoti Mahadeva. Like, just by knowing these theoretical aspects, what will I do? So tell me about the Yantra Mushagni Manani. So tell me about the apparatuses, tell me about the contrivances. So that's how the chapter begins. So then he goes about describing various, the Koshtika, Vakranala, then, so like different yantras get described in the subsequent chapters. So this is Tiryak Patana Yantra or Dola Yantra, where you want to kind of hydrolyze a particular object. What you see on the left is a closed one, the cross section is what is seen in the next. This is the Triyak Patana Yantra, which is still used in the chemistry lab. All of them are still used. It's just that it is not made with mud, it is made with glass now. So the distillation apparatus is still used. So you find it still in the Kannauj, if you go, the perfumery is still being made using this. Then this, interestingly, this is called Vrintaka Mosha. The Vrintaka Mosha is described in this way. I'll not bother you with the English, the Hindi, the Sanskrit words of it, but this particular thing was an invention over a period of time. This description is not found in the classical text, nor in the Vedic text. Now, this was specifically used for extracting zinc. Zinc, as you may be aware, is a very peculiar metal because the moment you liquefy it, the temperature of boiling and vaporizing is very close compared to the other metals. So much so that when the moment the zinc comes to liquid form, it immediately vaporizes. So collecting that is a it's a non-trivial task. So these people kind of, how did the optimization happen, we are unaware of. But we find in these texts, both in Rasaranava and Rasaratna Samuchaya, about this Vrintaka Mosha, that is a brinjal shaped crucible, where it is made of two crucibles. One is buried under the ground, which is empty and having a very small opening on the top, and the other one is inverted, filled with the zinc ore, calamine, the zinc ore, and then the heat is applied from the top. So the ore, the chemical reaction happens, zinc gets produced, and by gravity the zinc comes down. And after a certain point, when the reaction is completed, this hole kind of gets clogged. And after 24 hours, when all the heat gets dissipated, you remove the top one, you take the buried one pot out, and you have pure zinc metal. And this for the very first time was done only in India. There are international zinc authorities which have given it all the credit that it was the Indians who were the earliest manufacturers of tens of thousands of pounds of zinc. Okay? And that was, this particular Musha was what used for zinc excavation, zinc extraction. Not just that, they knew what is the difference between Durdura and Karavedlaka, which is nothing but zinc versus zinc oxide. So zinc and zinc oxide, pure zinc will appear, it has a different luster, zinc oxide will be different, which means that they have words, means they could recognize it. That's what I'm trying to hint here. Now quiz time. For those of you who had chemistry background, I saw two hands. This is a text, Avartamane Kanake Pita Tare Sita Sama Prabha Shulve Nila Nibha Tikshne Krishna Varna Sureshwari. I would just like the chemistry students or chemistry background people here to just guess what it could actually refer to. Any idea? Avartamane, Kanake gold, Pita yellow, Avartamane Kanake Pita, Tare Sita Samaprabha, Shulve Nila Nibha, Tikshne Krishna Varna Sureshwari. Give a guess, wild guess. Yellow color gold, I told you. Yes. More than that, please sit, you can sit and answer.
Can you please repeat once more? I cannot read the Sanskrit, so it's a problem.
Don't worry, you don't have, that's why I'm saying you don't have to translate it, but I'm asking you that if you read this, what comes to your mind immediately? Like if I give you some, there are some competitions, no? If I say some word, what picture comes to your mind immediately?
Yes, yes. Comparison to the stars and like that's a glittering, something which is very much have a glow as a glowing
Okay, good.
appearance.
Correct. Sorry? Yeah, it's a flame color. It's a flame color.
Yes.
And what does it tell you? Flame color means in high school we used to do a salt test, right?
So
We
sodium
introduce-
test, golden yellow.
Sorry?
Golden yellow, sodium flame test.
The
So go,
salt, cation analysis or anion analysis, you do flame test. You
yes,
introduce
sir, sodium
this
flame
cation-
test.
Yeah.
Golden yellow.
Yeah, thank you. You introduce this, you get the flame color changes to this. For the very first time, that description is given in this text. And none of our chemistry textbook talks about this. Okay. So, Shulva is actually copper. Incidentally, sulfur is a word coming from the Sanskrit word Shulvari. Shulvari becomes sulfur. Now, Shulvari, how does it come? Shulvasya arihi. What is Shulva? Copper. Because at that point of time, their reaction standard was measured with respect to sulfur. And copper was very much reactive with sulfur. So, copper's enemy was sulfur. So, Shulvasya arihi iti Shulvari. Sulfur was Shulvari. And from Shulvari, you get the word sulfur. Okay, etymologically it has been traced. So, if you introduce copper, the flame changes to blue color. Shulve Neela Nibha. Krishna Varna Sureshwari. Tikshne Krishna Varna Sureshwari. Tikshna again is iron. One form of one oxide of iron. Then the flame color changes to blackish. So that's how this is Vange Jwala Kapotabha Nage Malini Dhumika. So Vanga is tin, Naga is lead. So every salt when they are introduced to the flame, how the color changes is described here precisely. So this is not empirical, or this is not, somebody sat in meditation and saw a dream revealing something in written. Unless they would have done some scientific analysis, they would not have been able to write this. Now this is, again I am quoting one professor from IIT Kanpur, A.K. Vishwas, when he was analyzing Rasarnava, what he writes, okay? Procedures were described for making metal from Makshika, Vimala and Sasyaka. These are three different ores, Makshika, Vimala and Sasyaka. The first two being pyrites bearing copper and third being copper sulfate. Now for those non-chemistry background, copper sulfate, every metal appears as its ore, okay, either as sulfate or carbonate or oxide, okay. They are called ore form. Iron appears as iron oxide, and then we'll have to get it to the industry, process it, convert iron oxide to iron to make it usable. Okay. Now what this Bishwas writes is that the wonderful observation was made that all the three red products seemed to be identical. So whether you start from Makshika or Vimala or Sasyaka, which are very different appearing ores, when you process it, at the end you get only copper. That knowledge they had. And he says, this observation made centuries before the discovery of elements and Daltonian chemistry cannot be belittled. So this is really reductionism in place. Okay. Anyway. Not just that, the Rasarnava, we again see this verse. Suvarnam, Rajatam, Tamram, Tikshnam, Vangam, Bhujangamam, Lohantu Shadvidam Tacha Yatha Purvam Akshayam. Akshaya means, Kshaya means decay, disintegrate. Akshaya, that does not disintegrate. So this is the order in which the metals are placed which does not disintegrate. What is the order? Suvarnam, Rajatam, Tamram, Tikshnam, Vangam, Bhujangamam. Gold, silver. So today in the chemistry we learn it as electrochemical series. Of course the list is expanded, but at that point of time whatever they knew, they arranged it in a chemical reactivity sequence, they arranged it. Okay, so that cannot be just like that ignored. Of course there's a mistake here. In this they have placed Suvarnam, Rajatam, Tamra is again copper, Tikshna is lead, Vanga is lead, Bhujanga is tin. The order is slightly reversed, so but that anyway we can give it a benefit of doubt for their error. Anyway, so these are about the putas described in the text, but again I will skip the details. Just show the continuity that even the Rasa Jala Nidhi by Bhudev Mukherjee, this book came out in 1920s or 30s, and he followed the similar style of Rasarnava and Rasaratna Samuchaya. Just to show you that this tradition did not die away. Okay, this tradition still continued, but it's just that in the last 100 years we have been kind of very silent about it. I'll skip this part of translating it to my experiment. I'll spare that due to want of time. Yeah, so my last slide here, what I wish to write is to talk about the style of writing the text. Okay. Now this motif that I show here, an elephant crushing the lion's head. How many of you have been to Bhubaneswar, Odisha? There you will see this motif in the Konark Sun Temple at the enter Dwarapalaka, a huge gigantic elephant crushing the head of a lion. Go to any temple in South India, you will see this motif. Either elephant crushing the lion or a lion very powerful and an elephant next to it. Okay. And see the text which I have accompanied here. Naso asti loha matango yam na gandhaka kesari nihantvad gandhamatrena yadva makshika kesari. To translate it in English, naso asti loha matango. There exists no elephantine metal that cannot be subdued by a lion-like sulfur. We know the king of jungle is lion, but how does the lion establish its prowess? Only by killing the elephant. Because elephant can easily vanquish the lion. So the lion comes and attacks the elephant from the back, and then it kills the lion, and that's how the lion establishes its prowess of the jungle. So see that the acumen of the textbook writer, chemistry writer, today it's all very dryly written, but see then, the cross connection of the nature, the ambient, the general knowledge that people possessed back at that time. There exists no elephantine metal that cannot be subdued by lion-like sulfur. Okay. So why I'm saying this is today NEP talks about interconnectivity, cross-sectionality, so on and so forth. What best example can we have from this, especially for a given subject like chemistry, which is normally pursued as a very, very dry subject. Okay. So with that, I thanks once again the organizers and your patient listening despite sleep overpowering you and listening to me with attention. Yeah, please. There are descriptions of these kind of adamantine glues mentioned even in those Vajra Lepa, all these adamantine glues are described in those Vastu Shastra text. Shilpa Shastra text also has. Even today, if you go to any South India and a temple, Jirnodhara of a temple happens, the Murti Pratishtha happens once again, where even today they make those adamantine glue. They will put it on this is, I'm not talking about the temple Gopura, but on the Garbhagraha, where the Murti is again, Punarstapana of the Murti happens, you make the glue again. So it's, yeah. Ashtamangala is a generic term. Ashtabandha, yeah, Ashtabandha, exactly. They use that. So this is still in vogue. The descriptions are given in the text about how the stones have to be locked with each other.
Yes. Sir, we have heard about Rasabhavi in the sense the well of Rasayana in the descriptions in the anciently, and we have no such some places in Karnataka, Rasabhavi. Any description of that? And second question is, the Swati rain has the curdling property. when Swati rain, water is put into the milk, it has it turns into a curd. That is how the new culture is done every year in Karnataka. Is any chemical aspect to that or any ideas?
About second question, I'm sorry, I'll have to show my ignorance because I have not read about it. Please sit. Rasabhavi, I have come across that term, but I have not given a very serious thought to it. I have to read more. But my just opinion on that is like, say the word Rasarnava itself. It means ocean of rasa. That doesn't mean physically we will have an ocean of mercury. It could also be, because titles can have atishayokti in them. So in that sense, if Rasabhavi was used as an adjective to describe something else is what we need to look at. But definitely I will have to read more on that. I'll come back after reading it. About the second question, I do not know. I have not come across. Shankha Dravaka. It's sulfuric acid. Sulfuric acid. Acid. H2SO4. Thank you.